I was not satisfied with any of the how-to videos I watched on the building of stair stringers. However, I was able to pick up some valuable tips, and I feel like I've consolidated the better ideas into this 8-step video. Remember to always check your local ordinances before building any structure. Now let's get after it. Today I will explain how I calculated and cut these stair stringers. If you stick around to the end, you can also watch the assembly. Using this diagram, note that our first measurement shows the top of the deck with the decking material already in place. Without any other information, we don't know where the bottom of the stairs will hit this uneven ground. Step 1 is a measurement from the edge of the deck to the ground. This will give us a starting point to find the number of stair risers. If the decking is not already installed, lay down a piece of it as shown in preparation for the first measurement. Take a measurement at the center of what will be your steps from the ground to the top of the decking material. Our measurement is 30 inches. We will start with the industry standard for a riser, which is 7 inches, and take our 30-inch height from step 1 and divide by 7. Since the resulting fraction was 0.28, we round down. That gives us a starting point of 4 risers. Now it's important to note that although the result is 4 risers, 3 of them will be cut into the stringer as shown here. And 1 riser will be attached to the face of the deck at the top of the stringer. Observe the 4th riser located here separate from the stringer. In fact, the top of the stringer ends here and the bottom of the stringer starts here. The run is described as the total depth of the treads with spacing and overhang. Overhang should be 3/4 to 1 inch on the front and on the sides. We're going to use the same boards for the treads as we did for the decking, and each deck board is 5.5 inches wide. So we'll need 2 boards per run. We'll need to calculate for spacing and overhang, and this is the way the calculation looks to figure our run. We're going to use this calculation so that by step 6, we will know the actual height of our risers. This is a nifty trick to figure the actual drop from the top of the deck to where the end of the stringer actually touches the ground. Following the result from step 4, measure out from the edge of the decking 31.5 inches using a ledger board. Then measure from the bottom of the ledger board to the ground. Since we're installing the stringers on an uneven surface rather than a flat concrete floor, this measurement will most likely be different than the one in step 1. Allow me to illustrate. Our final calculation is used to find the riser height suitable for our build. We use the distance to the ground in step 5 and divide that number by the original number of risers in step 2 to get a final riser height of 7 3/8 inches. Now we have all we need to begin. We know the run length and we know the riser height, so let's use it to build this cardboard template. Now these are called framing square gauges. Although not necessary, you can use these as an inexpensive way to keep your measurements intact while you mark for your stringers. I highly recommend the use of a framer's square. We placed painter's tape on our square for illustrative purposes of this video. The gauges are placed on the square so that the edge of each gauge touches the appropriate number on the square. Then they are finger tightened in place. Let me show you. Here is 7 3/8, and here is 10.5. Now for the fun part. You don't have to use a cardboard template, but if you do, lay it as shown and begin at the left side by hooking the edges of the gauges over the edge of the template. and then mark along the top edge of the framer's square. I'm using a Sharpie for illustrative purposes, but a pencil is a better choice. Pick up and slide the square to the right, being careful to line up the left gauge to allow yourself room for the next line to touch the first. And then mark your next run and rise, and move the square again and repeat. And remember, in our case, only 3 risers are necessary, so this is our final move of the framer's square. Locate a straight edge and extend the last line all the way through to the other edge of the cardboard, like this. For orientation purposes, I'll mark this side as the top of the stringer. Now it's time for you to make a decision. If you choose to leave your risers open, like this example, you're finished with the top of the cardboard template. Or you can choose to enclose your risers, as in my example, in which case you'll need to know the thickness of the riser material. Now, my riser material is 3/4 of an inch thick. We need to allow for this thickness on our template by doing the following. Using your square, measure back toward the inside of the stringer by the thickness of the riser, in my case, 3/4 of an inch. Take your straight edge and connect the dots. Now I like to mark an X on all material I'm going to remove. In fact, we're going to cut away all this material in yellow. And the neat part is, instead of having to make this cut 3 times representing each riser, we only have to make this one adjustment and it will properly reset our entire stringer and move it slightly backward to account for the thickness of all the risers. Continue to cut along the lines until you get to the bottom end of the template, being careful not to cut into your table or workbench beneath the cardboard. Now, working on the bottom of the stringer, just like with the top, we continue this line all the way through to the opposite edge. Next, determine the thickness of your treads. We're using decking material that is 3/4 of an inch thick. Measure inward toward the stringer 3/4 of an inch to match the tread thickness. Again, this one cut adjusts the stringer downward to account for the thickness of all treads. Connect the dots, mark with an X. This time we're going to remove the entire portion in yellow and in blue. We make our cut using the square as a guide, noting that we have already pre-cut the riser portion, so just pop out the finished stringer. Because I cut off my label, I relabeled the bottom end. And here is the finished template. Now at the job site, we check our template by laying a 3/4 inch piece of scrap wood on top of the first run to measure from the ground to the top of the tread, which, if you recall, should be 7 3/8 inches. And then we add the second and third piece of scrap wood, measure from the top of one tread to the top of the next, and finally take a measurement from the top tread to the top of the deck. This looks good. Now if you look closely, you'll see 2/3 of the top of the stringer hang down below the deck face. Leaving this as is would not be good, as we would not have much wood to use for attachment points. So we're using a 2x10 and we fashion and attach an apron underneath the deck edge. And now we have additional attachment points here all the way to here. Place your template on a treated 2x12 and trace around it in preparation for our first cut. Using a handsaw, jigsaw, or circular saw, make the cut. Now on these inside cuts, using a circular saw, cut up to the edge of your line, realizing that the cut will not go all the way through the wood. As you complete the second cut, support the cutoff piece and grab your handsaw or jigsaw to complete the cut. Continue on down the stringer, making your cuts. Once this first stringer is cut, mark it as I did here with a T, for example, to use this piece for tracing on all other stringers, as this will be your template. The widest span of my stringers will be only 34 inches, and as such I could get by with only using 2 stringers. The rule of thumb per my local ordinances are 3 stringers per 36 inches of span. However, I had an extra 2x10 scrap that I decided to cut as a 3rd stringer. You see it here in the center. Note, however, that using a 2x10 as opposed to a 2x12 means you sacrifice some additional strength, as you can see by the difference here in the width at these 2 points. For our 34-inch application, this will be fine. Anytime you make a cut to or puncture treated wood, you should seal all the cut edges. Here we're using clear polyurethane. 2 coats are recommended. This dries quickly, but watch the fumes if you're doing this indoors. Back at the shop, one of the other ideas I adopted was cutting a key slot in the base of all my stringers and tying them together with a treated 2x4. This allows for added rigidity during assembly. Let me show you how. Start by stacking the stringers on top of each other and aligning a scrap 2x4 vertically. Using the Sharpie, I establish a cut point by tracing around the 2x4 on all the stringers. And then transfer the 2x4 to the top of the stack and trace around it once again. Remove each marked section on all the stringers using a jigsaw, and then cut your treated 2x4 to length and fit it in place. Here we pre-drilled and attached the keyway 2x4 using 3 3-inch deck screws per stringer. Attach the outside stringers first. You can use your carpenter's square to keep the pieces aligned while attaching the screws. Once we determine the halfway point of the 2x4, we centered and attached the 3rd stringer in the same manner. Care should be taken in the transport of this set of stringers, as the top of the stringers remains unattached at this point. Our next move is to excavate and bury these 3 pavers beneath the point at which the stringers touch the ground. Using a spade shovel, we outline the area where the excavation will occur. And then enough soil will be removed to where the pavers will set level. The pavers have now been installed with the set of stringers temporarily in place. Another use for this keyway 2x4 might be if you want to secure the set of stringers directly to the ground using landscape nails or screw it in the concrete. We have marked and pre-drilled a hole to mount our first stringer lag bolt using an impact wrench. I will install 2 lag bolts per stringer. I located, pre-drilled, and temporarily mounted this board to brace all 3 stringers and kept them level while I finished their attachment to the deck face. In addition, I made witness marks to ensure the stringers don't slip during the attachment. As we pre-drill and attach the lag bolts to the other outside stringer, note that because of the position of the center stringer, I only have room for 1 lag bolt due to the brackets in the rear holding up the deck joist. Because of this, we will incorporate the use of these L-shaped brackets for additional support to be nailed on either side of the center stringer using galvanized deck nails. Once all the stringers are attached to the deck, use a 3 or 4 foot level to check accuracy. We now remove our temporary brace. The 4 risers have been cut and temporarily set in position. Align, pre-drill, and screw these risers into place. We used 3 screws per riser per stringer. Because we drilled through the protective polyurethane barrier for the brace, we reapply it to the screw holes. In fact, this is a good time to apply polyurethane to any missed areas or reapply a fresh coat. This final piece of the project is installing the 2 treads per run. Cut the treads so that 3/4 to 1 inch will hang off each end and leave approximately 1/8 inch spacing between each tread and the tread and the riser to help water run off. We're also measuring to make sure we have our 3/4 inch overhang. Pre-drill and mount 3 screws per tread per run on each stringer. Note the overhang on each end of the first set of completed treads. Now cut to length, pre-drill, and mount the treads for the second run. To assist with screw alignment, you can set an angle square in place and make a light pencil mark, and then follow the mark for precision drilling. As we wrap up this project, don't forget to use your polyurethane to seal the screw holes. Once the sealant is dried, we try out our new stringers, and then come back the next day to apply the decking material for a project complete.